Congruence of triangles. Congruency test for triangles. Introduction. Congruence among segments and angles. Congruency of triangles. Properties of congruency in triangles. Tests for congruence of triangles. SAS test, ASA test, SAA test and SSS test. In this chapter, we are going to learn about congruence of triangle. Tripti was confused and could not understand topic congruence. So, she went to Sheetal. Sheetal solved her confusion. These two coins, if we put one above other, what do you observe? Tripti says, one coin over the other completely. Sheetal says again, right, covers completely and exactly too. It means two coins are of the same size and same shape. Such objects are said to be congruent. Sheetal says, two shaving blades of the same size, biscuits in same packet, page of same letter pad are some examples of congruent figures. Congruent figure. Two figures having same shape and same size are called congruent figure. And the relation of two congruent figures is called congruence and shown by sign. Congruence among the segment. Sheetal says, the length of segment AB and segment MN is same. We can say that segment AB and segment MN are congruent line segments. It means if segments are congruent, their lengths are same. Congruence of angles. Sheetal says, Tripti, same way, angles of same measures are said to be congruent to each other. Here, angle ABC is congruent to angle PQR as both are of same measure, that is 40 degree. Congruency of triangles. Sheetal says to Tripti, Tripti, let us try congruence relation with triangles. This is triangle ABC and this is triangle PQR. Now let us see whether these triangles are congruent or not. Sheetal says, vertex A exactly placed on vertex P. Vertex B exactly placed on vertex Q. And vertex C exactly placed on vertex R. Again, side PQ covered by side AB, side QR covered by side BC, and side RP covered by side CA. Tripti says, both are of same shape and size, hence both triangles are congruent. Triangle ABC is congruent with triangle PQR. Sheetal says, this sign represents the relation of correspondence. We pronounce this sign as corresponds to. This relation binds vertex with vertex, side with side and angle with angle of two triangles. It makes the way easy to find congruence between two figures of same shape and size. Through the relation ABC corresponds to PQR, we say that triangle ABC congruent to triangle PQR. Hence, we get pairs of congruent angles and congruent sides. Therefore, angle A congruent to angle P, angle B congruent to angle Q, and angle C congruent to angle R. And side AB is congruent to side PQ. Side BC is congruent to side QR. Side AC is congruent to side PR. To prove congruency of given triangles, any three of these 6 conditions should be satisfied by triangles. Properties of congruency in triangles. 1. Reflexivity. A triangle congruent itself. 2nd, symmetry. If first triangle is congruent to second triangle, then second triangle is also congruent to first. Transitivity. If first triangle is congruent to second triangle and second triangle is congruent to third triangle, then first triangle is also congruent to third triangle. Test for congruence of triangles. Tripti says, Sheetal, how do we find the congruence of two triangles if correspondence relation is given? Sheetal says, for that, some criteria is given. We call such criteria as test. We have some tests to study. Let us see one by one. SAS test. Now let us take another two triangles. These are two triangles having two respective sides of same length and one angle between these sides of same measure. Now, if we arrange these triangles one above other to look for similar shape, we get the correspondence relation as ABC corresponds to EFD. Under this relation, we have AB is equal to EF is equal to 7 cm. BC is equal to FD is equal to 5 cm and angle B is equal to angle F is equal to 50 degree. Hence, triangle ABC is congruent to triangle FED. Tripti says, if under a given correspondence, the two sides and an angle between them of one triangle are equal to the corresponding two sides and an angle between them of another triangle, then the triangles are congruent. Isosceles triangle theorem and its converse. If two sides of a triangle are congruent, then the angle opposite to them are congruent. Given that PQR is an isosceles triangle and side PQ congruent to side PR, we have to prove angle Q opposite to the side PR and angle R opposite to the side PQ are congruent. Draw an angle bisector of angle QPR which intersect side QR at point P. Now we get two triangles, triangle PQS and triangle PRS. In these triangles, segment PQ is congruent to segment PR is given. Angle QPS is congruent to angle RPS. Angles made by bisector and segment PS is congruent to segment PS, common segment that is. Hence, by SAS test, triangle PQS and triangle PRS are congruent. Therefore, corresponding angles of congruent triangles, that is, angle Q and angle R, are also congruent. ASA test. Sheetal says, if under correspondence, two angles and the included side of a triangle are equal to two corresponding angles and the included side of another triangle, then the triangles are congruent. Let us prove it. These are two triangles, triangle ABC and triangle DEF. We have given angle ABC is congruent to angle DEF. Angle ACB is congruent to angle DFE. Segment BC is congruent to segment EF. If segment AC is congruent to segment DF, by SAS test, we can prove triangle ABC and triangle DEF are congruent. But what if AC is greater than or smaller than DF? That is, AC is not equal to DF. Consider AC is greater than DF. Therefore, we take a point D dash on ray FD so that D dash F is equal to AC. Now in triangle ABC and triangle D dash EF by SAS test, we can easily prove that triangle ABC and triangle D dash EF are congruent. Hence, angle ABC is congruent to angle D dash EF. But we have already given that angle ABC is congruent to angle DEF. Therefore, Angle D-EF is congruent to angle DEF. This is possible only if D and D' are same or coincide. Therefore, triangle ABC and triangle DEF are congruent. SAA test for congruency of triangles. Sheetal says, for a given correspondence, when two angles and a non-included side of one triangle congruent to corresponding angles and the side of another triangle, then the two triangles are congruent. Now let us prove this. In triangle ABC and triangle DEF, we have given angle A is congruent to angle D, angle B is congruent to angle E, segment BC is congruent to segment EF. We know sum of angles of triangle ABC is 180 degree and sum of angles of triangle DEF is also 180 degree. Therefore, equation 1 and 2 are same as their right hand side is same. As angle A is equal to angle D and angle B is equal to angle E, angle C also equal to angle F. Now in triangle ABC and triangle DEF, we have pair of congruent angles and congruent sides included in angles. Hence by ASA test, triangle ABC is congruent to triangle DEF. Side test or SSS test. Sheetal says, Tripti, let us see these two triangles, triangle ABC and triangle PQR. The length of sides of respective triangles is given. AB is equal to 3.5 cm. BC is equal to 7.1 cm. AC is equal to 5 cm. PR is equal to 3.5 cm. PQ is equal to 7.1 cm and QR is equal to 5 cm. If we observe both the figures, we can see that length of AB is equal to length of PR is equal to 3.5 cm. Length of BC is equal to length of PQ is equal to 7.1 cm. And length of AC is equal to length of QR is equal to 5 cm. Therefore, for ABC corresponds to RPQ. Three sides of triangle ABC are congruent to three sides of triangle PQR. Hence, triangle ABC and triangle PQR are also congruent. Sheetal says, if under a given correspondence, the three sides of one triangle are equal to the three corresponding sides of another triangle, then the triangles are congruent. To prove this SSS test, take two triangles, ABC and DEF. The congruent sides are shown in figure. Construct angle PEF equal to angle ABC and angle PFE equal to angle ACB. We can easily prove that triangle ABC is congruent to triangle PEF. From these congruent triangles, we get following congruent pairs and set some congruence relations too. Now in triangle DEP, we get these two congruent pairs. And in triangle DFP, we get another two congruent pairs. If we add the equation 3 and 4, we get angle EDF is congruent to angle EPF. Now in triangle PEF and triangle DEF, we get three sufficient conditions. That is, two pairs of congruent sides and one pair of congruent angles. To prove triangle PEF and triangle DEF are congruent. Now we have triangle ABC is congruent to triangle PEF and triangle PEF is congruent to triangle DEF. Hence, triangle ABC is congruent to triangle DEF. Summary. Dear students, in this topic we have learnt introduction and congruence among segments and angles, congruency of triangles, properties of congruency in triangles, test for congruence of triangles, for example, SAS test, ASA test, SAA test and SSS test. So that is all in this subtopic. We will learn some important theorems in our next topic. Till then, bye-bye.